Hi, this is Chong Kim. Welcome to Ruby Chess version 3 part 2. Okay, let's get started. Alright, last we checked, everything was running fine. So let's save. Okay, it looks fine. So before we do anything, it's a good time to refactor. So let's take a look at the code and try to make things a little bit more readable. One thing I noticed was that with valid move, there was actually two ways to make a movement. One is a regular move to an empty square or a capture. And I didn't think of this at first, but because the logic became very um, complicated, it was really complicated because I had to test whether or not the target piece um, was an empty square or not. And that's because things acted a little bit differently when it's a capture. So I'm going to separate this into two parts. One is a valid move and the other one valid capture. And I decided for a naming convention that if there's going to be arguments, I'm not going to put a question mark. Um, all right, so um, let's see. So let's break this up. Valid capture from 2. Okay, so we get the dx and dy, and really the only differences are with the king and pawns. So if it's a pawn, then the dx is going to be 1 or -1. So let's get the absolute value. And the dy is going to be just one move, because it can't jump 2 squares for a capture. All right, so we have that condition. And for the king, um, then we have the same thing here. So we'll just copy that. Okay, and otherwise everything else remains the same. So else we'll just say valid move from 2. Okay, so this seems to take care of the capture. But for the actually okay, yes. So capturing happens on the diagonal. King can capture when it moves 1 square. But for the valid move, the king can move 1 square, or it can go from depending if you're white or black. So based on a turn, so it can either go from the e1 square or the corresponding e8. Oh, it should really be equals. And the 2 square, so it depends. So the 2 square, you can go to two different places. One, it could be based on a turn, it can be on the g1 square, or it could be let me just break this up now. So I'll put parentheses here so that the so it'll line up a little bit better. Okay, so from white to this, and turn could also be on c1. The king could move to c1. Okay, so the first one would be the short castle, or the regular castle, and this will be the long castle. All right, so that's in addition. So we can take this away. We don't need this line, so we can close this up. And because it's always going to be dx, so we can just say dx is equal to and. So we can factor that out. Okay, and let's see. Okay, so let's see if this reads well. Okay, so oh, actually I forgot the 0 here. All right, so if it's a pawn, then it has to be in the same column, but you could jump 1 square or jump 2 square if it's from the home row. Okay. I also noticed I forgot the queen here, so let's put the queen. And the queen movement should act like a bishop or a rook. Okay, so that fixes that up. Let's close this up. Okay, so this looks pretty good. Captures over here. And, right. So let's go down to the move piece. The move piece was where I had a lot of problems because there's too much logic in here. It's not that there's assignment statements and stuff, but it's what they represent. It just represents a lot of logic. So let's just get rid of it and let the tests tell us what to do. Actually, the only thing that we're going to keep is the movement of the piece. So, right. Okay, so let's, oops. All right, so let's just, okay. It expects the rook to move like a rook. Okay, that's what it's saying. We don't need this. So, okay, so I don't even know if we need the piece any. Yeah, we probably do. Okay, so if, now there are two conditions. There are two kinds of moves, and that's based on is captured, so whether or not you're captured. And that is determined whether the piece is blank. But a capture can also happen through en passant, and your, actually that's the piece. We need a target piece. Is 2. So the target can be, actually it'll be not empty, or it could be empty, but it's an en passant. So is en passant capture. Okay, so is en passant capture, how do you determine if it's en passant capture? Well, if it's a pawn, so piece is a pawn, and the 2 square happens to be the en passant square. So you're going to the en passant square. Okay. Actually, this kind of reminds me of the color function, the other color. We don't need this anymore, because the reason why is because we were trying to determine about capturing, and so we're doing it in a different way. Okay, so we're back here. So is capture, if it is a capture, actually let's start with not a capture, is not a capture, then we have to check if it's a valid move from 2. And then we want to make sure that the path is clear. So path clear of from 2. Then we're able to make this move. All right. All right, so we passed that point now. This is saying that the rook is able to capture a piece. So we have the condition here of if it is a capture. If it is a capture, then we want to check if it's a valid capture from 2. And we also have to check path clear. But since path clear exists in both, I'm going to group them together. So I'm actually going to move this outside and just put this as an OR here. So let's see if this reads well. Let me see. We still need to put the then. Okay. Okay. So this says if it's not a capture, then check to see if it's a valid move. If it is a capture, then we check to see if it's a valid capture. So basically these two bind together. And after either one of them, actually that means that this parentheses have to be there. After all of this, then it checks to see if the path to that location is clear. All right. All right, this is still a problem. It says it's, oh, this is capturing your own piece. So this is a little bit different. So you're not allowed to capture your own piece. This is a white rook with a white pawn. So we'll put a condition here saying that return nil if the piece color is equal to target color. Okay, so that's like a general rule. Okay, turn 4K symbol on 31. Actually 31, but 135. 135. Ah. Okay, so we probably have something wrong in here. Let's see where the error is. The error is, it says chess 135, so we were there, and valid move 31. Okay, so 31. Okay, let's run the ctags, just to make things a little more updated. Okay, so we can go there. Okay, so there's a turn self. Right, because it should be turn, it should be self. Okay, so change all these to self. Okay, now this is saying that the en passant square should be set. So if you move 2 squares, it should be en passant. So let's put a condition here. So how do we know if it's an en passant? Well, first, if it's a pawn move. So if the piece is a pawn, and the movement that you make, so 2 minus from, we take the absolute value, and that's equal to 2. So basically, not 2, 16, because there are, so if you move 16 squares, then you go up 2 rows. So we're doing the absolute value. So for either piece, if you move 2 squares, then we want to set the en passant. Actually, we could just do it right here, saying en passant is equal to, if you move 2 squares, then it's going to be average of the 2. So 2 plus from divided by 2. Otherwise, it's nil. So that's the en passant. Okay, this one says it's an en passant capture should remove the extra pawn. So we have the condition. So you can say if is en passant capture, then we want to remove that. So let's see what it looks like. So if you have something looks like this, let me just move this over. All right, so let's say that the pawn is here and the opponent's pawn is there. I use an A. Well, this is where the pawn is going to go, and you need to take this one away. So this is the from, this is the 2, and this is the square that we need to get rid of. And okay, so if we were to write the code, it would be something like, okay, let's write it up here. So it would be something like the square, it's on the same column as the 2. So 2, and it's the same row as the from. So from's row, and we have to multiply by 8. Okay, so this would be the location, and we'll just clear that out. Okay, we can get rid of this. Okay, so let's see. Everything passes. All right, great. So this code is a lot simpler than what we had before, and it's very readable. So I'm happy with this version of the code. Okay, so let's do the next steps. The next step is to run through the code. Actually, run through some moves. So let's make sure that everything is set up before we read the PGN file. So let's do the E4. So let's see. Set up. Okay, so we start with a new position, and we move E4. Okay, and when we do that, we expect that actually what I want to do is I want to get rid of, okay, so for the subject's E4 square, that's going to be a pawn. And the subject's E2 square, is going to be blank because this is where it came from. I want to change this notation. Initially, when I wrote the test, I had E4, E2, D1 as returning the character, the piece that's at that location. But when I had this referred to the index position, not the content of the position. So it's confusing, and also I'm going to have problems with this later on. So I'm going to fix this now. So I'm just going to convert this to subject E4 is equal to blank, and this one becomes subject E2 is a pawn, subject D1 is a queen, got the bracket, and the subject D8 is a black queen. There aren't too many places where I have this, so it shouldn't be too hard to get rid of it. Subject E4 is a rook. Subject E2 is blank. Okay, let's take a look at. All right, I think that's it. All right, so also in this code, in position, see where okay, here's the code where that's being set up, so I'll just get rid of that. And okay, and this test. Okay, so all right, so let's write the rest of it. So the turn should be black now. It's, let's see, castling should still be the same. King, queen, capital Q, king, queen. And en passant is nil. Half move 0. Full move is 1. Okay. Now we move to E5. Okay. So E5. That's E5. Okay. So E5. Move E5 and expect E5 to be a black pawn, and that came from E7. Turn should now be white. Castling same, en passant. Actually, en passant should be E3 squared because you move 2 squares. And this should be E6. Half move is still 0. Full move is now 2 because it's white's turn, and it'll be the second move for white. Okay, next. Now we do knight F3. So knight F3. Okay, so that would be the F3 square. That's a knight. That came from G1. Turn now should be black. Castling same. En passant is now nil. Half move starts a count now because it's a piece move. Full move is black's turn, so it doesn't change. All right, next. Knight F6. Okay, so it's F6, and it's lowercase n for black knight. That came from G8. Turn is now white. En passant is still nil. Half move gets incremented. Full move is now also incremented. Okay, next. Okay, knight takes E5. So move, knight takes E5. Okay, so that's the E5 square. And that should be a white knight. That came from F3. Turn is black. En passant, no, half move is reset. It's black's move, so it's still move number 3. Okay. All right, no method move. So let's start with the move. takes a string, and we'll have it raise illegal move self. Okay. Right. Okay. On initialize, so we'll create one illegal move, which is an exception, and that will be uh, actually it'll take argument of the string and a position, and it'll call the super with a string, new line followed by the position. While we're here, we might as well create the ambiguous move. And that takes an extra argument, which is a list, and we'll put it after the position, so space, and we want to map to square on it so we can read it, and we'll do inspect. Okay, so that'll show the ambiguous move. All right, so let's see. All right, this is part of 2s, so let's make 2s for that. So when we print out the string, it'll print the board, the turn, the castling, en passant, full move, and actually full move is here. Okay, and this will be the half move. Okay, so we start off with the board, which is we're going to change each of those characters. So we have the piece, and we'll take a look. So rook, knight, bishop, queen, king, pawn, rook, knight, bishop, queen, king, pawn. All right, and let's just map those. So, right. So a white rook, a white knight, a white bishop, white queen, white king, white pawn, black rook, black rook, black knight, black bishop, black queen, black king, and black pawn. Okay, so this actually it should be, yeah, it's a hash, and we fetch the piece. Okay, so this converts into a piece, and we're going to map. Okay, and then we're going to do this on it, which is okay. We have too many. I think we have too many. Okay, so that maps with that. Then for that, we're going to split it up, each slice 8, and then we have the row. So we're going to just join it with a space, and then join that with a character turn. So we have the board, and next, turn. So So white based on turn is going to be white or black. And well, let's just actually print this out. So let's just say it's a turn. So I'm just going to just put turn over here. Castling. If the castling is empty, then we're going to put a dash, otherwise we're going to join it together. And the en passant is going to be, if it's nil, then we just have a dash, otherwise we're going to do it's en passant, so EP. So en passant, we're going to turn it into a square so we can read it. Okay, so that takes care of it. And see where we go wrong. Empty for nil class. Empty for nil class. Castling. Oh, this is interesting. Where is it exactly? It's on 159. So it's right here. Castling. It says castling is nil, which is, oh, oh, that's because I have an assignment statement here like this, so it's supposed to be like that. Okay. All right. Actually, let's see, look for this or P. So it just defaults to itself if it doesn't find it. Okay, so now we have the dashes as well. Okay, so first one, illegal move E4. Okay, let's go fix that. So when, and we're going to look for the square. It's going to look like A through H, 1 through 8. Okay. Then when we find that we're we have the 2 square, so 2 is going to be, oh, actually this is the wrong way. If okay, so if it matches that, then the 2 part is going to be the m square, and then we're going to convert that into an index. And the piece is going to be, based on turn, it's going to be a king, or not a king, a pawn. White pawn or black pawn, depending on the turn. Okay, so that should be enough, and then otherwise we're going to raise an illegal move. And we have the 2, we need to have the from. So where is it coming from? So we can do that by taking a list and getting all the pieces of the pawn, which is the piece. This gives us a set. And we'll just convert this into an array. And then we do a select. Select all those, and this is the from part, where it becomes a valid move. So this is a pawn move and not a capture. So we can say, let's see, move valid from to. And we don't actually want to make the move, so let's pass in an argument and support this. We say false to not actually do anything. So just to check to see if it's a valid move. And at the end, right here, we're going to check if the list is empty. If it is empty, then we want to raise illegal move. Illegal move new stir self. If, okay. And for this, instead of raising it here, I could just say list is empty. Okay, or I could start off with an empty list right now and then just not have an else. So this way, this gets triggered by default if you don't find anything. Okay, and we're going to raise an ambiguous move if it's greater than 1, the size. Otherwise, we're going to actually do the move. So this actually does the move. All right. Okay, so let's see how it goes. We should have a problem with move valid. ToIndex first. Okay, so let's just create the ToIndex, and that's part of a string. Okay, so that takes the self, the first character, subtract the A from it. And we should do that as an ASCII character. And then we take the 8, character 8, and we subtract the second character from it. Okay, and then multiply it by 8. So this gives us the index position. All right, undefined method valid, move valid. Is it valid move? It's valid move, not move valid. Valid move. Okay, no method valid move for. That's because it's part of the piece. So piece valid move. Actually, we don't want just the movement. We want to see if it's move piece, because this will also check to see if the path is clear and if it's actually able to make that move. So that's what we want. Okay, wrong number of arguments because we just added one. So I'm going to update the C tags so I can jump to move piece now, because we've added a bit of code, and we're going to have act defaults to true. So anytime we see a state being changed, so this is a state being changed right here, en passant. So we say if act. And here's another one. So we say if act. And here's another one. If act, if act. All right, so I think we have all the assignment statements taken care of. Okay, undefined local variable from 178. Okay, 178. Okay, so it doesn't know about this from. Oh, that's because we didn't define it. So from is just the first item from the list. Okay, so we're doing pretty good now. The turn should be changed. So after we make a move, we're going to turn it. So the turn is, if you're white, then it'll be black. Otherwise, it'll be white. Okay. Oh, and this should return self. Okay, so let's see. Full move should be incremented when it's white's turn. So, okay, if it's white's turn, we'll do it over here. So we'll say full move is incremented by 1 if if the turn is white. This is after we switch turns. Okay. So those two. So everything passed up to that point. Now, is movement of pieces. So a knight. So we have to put a piece over here now. So the piece may or may not be there. So we put a question mark. We put an X at the end of this regular expression so we could put spaces here so make it more readable. All right, so this one is going to be the piece, and that can be rook, knight, bishop, queen, king. Okay, and we'll have it here so that M piece, or it'll default to a upon. But we're going to send, based on a turn, upcase, or actually we'll just say to sim, and then piece is equal piece downcase if turn, not turn. Yes, turn is black. Okay, if it's black's turn, then we just downcase it. We have to put an exclamation point here to make it actually change. Okay, oh, there's no downcase, so I guess like we have to do it this way. So piece is equal to piece dot downcase. Okay. All right. So let's see, half move. Okay, so because it's a knight move, not a pawn move, so we'll do it over here, saying that if the piece is not a pawn, then actually not then we want to increment the half move count. So half move count gets incremented to 1. Actually, a better way to say this is that if the piece is a pawn, then you want to say the half move is equal to 0 because you want to reset it. Otherwise not. But you also have to determine whether or not it's a capture. Is capture. All right. So how do we know if it's a capture? Well, the target piece. So it can either be, if it's not a pawn, then a capture is if the target square. So, or I could just self, the target square is, well, it's not empty. So, okay, so that would be that, not empty. All right, so half move, expected 1 but got 0, half move. So why is that? Oh, that's because this, we're looking at the target square after the piece has moved. So we need to have the move piece at the after it. Okay, so half move got incremented a little bit too much here. Actually, that is true. This is correct. The test is wrong because you've made two moves with the piece, one for white, one for black, so it should be a 2. So the test is wrong. So the test should, so the half move for this should also be incremented. Okay. Illegal move, knight takes e5. That's a new form. So let's just go and add that. So the x is optional. So x is optional. Okay, so everything passed. All right, so now we're ready to read in the file. Okay, so let's start with, I'll just say reads from PGN file. Okay, so so we open the file. It's under games morphy.pgn. I'm gonna read it. Okay, so we have that reference as f. So f.getS reads the line. So while there is a line, if, so let's take a look at how it looks like. So so we're going to skip all these header information that begin with brackets. So let's say if the line start with a bracket, then we want to just skip it. So next, if it starts with that. Otherwise, we'll take the line and, okay, let's take a look at it again. We have these numbers in the front. We want to just ignore those numbers. So we'll just get rid of it. Look for a word boundary, a digit, more than one digit followed by a dot and replace it with empty, so basically getting rid of them. Split and do. We're going to move M, and we're going to do that on the position. We need to create the position first. Okay, so we create the position, and I think this is good. We're ready to test this out. Undefined method context. Oh, I wrote this in the wrong place. Just delete it. Okay, and put it right here. Okay, all right, so let's see. Okay, so far so good. It went through files, it went through the moves, and now E takes F5. So it's because of this E here. All right, let's go fix that. So right after the piece, there can be a specifier for what where the piece is. So it could be a column, which is going to be A through H. We'll just put a question mark there. And it could also have a row, which is 1 through 8, and put a question mark there. Okay, so let's see. Make sure the parentheses match. Okay, so we have these two parts. Okay, so since we wrote it, we might as well write the code that goes along with it, and that is we filter it out. So so the column is going to be mcol, and if you subtract the ASCII character A from it, then we get the column number. And so we want to check that the from column is equal only if it's set. Okay, so we're going to do the same thing for the row. So to calculate the row, it is divided by 8, and we subtracted from the ASCII value 8, and this is the row. Get rid of this. Okay, and we check for the row. Okay, so and then now we have this check that we need to handle. Okay, so optionally it may have a plus. Okay, castle. All right, instead of adding castle to here, I'm going to create another condition if it is equal to a castle. So I'm actually going to do it both ways. So okay, so we're going to put castle and long castle here at the same time. Actually, it should have been parentheses because this may not be here, and a $sign. Okay, so it matches that. Then let's see. The piece is going to be a capital K or a lowercase k. From is going to be the same in either case. So it's going to be E1 for long castle and short castle. 2 is going to be different. So it depends. So if it's a short castle, then 2 is going to be short castle is going to be G1. G8, the corresponding G8. Otherwise, the 2 is going to be C1. Oh, so we can actually factor out the 2 and make this into a ternary and say this. Okay, so it's either going to be so it depends on if it's a short castle, it's going to be G1, long castle is going to be on C1. All right. Okay, so let's see. Oh, we still got illegal move for the castle. Interesting. Let me see. Did I do this right? Here it is. Let's see if we got to this point. It's hard to tell. Let me just put a debugger in here. So it should stop if it got there. Okay, so it's able to get there, but oh, that's why, because of the list. That's right. All right. So the from square there is no from. It's the list. List is just going to be the starting point. Okay. All right. So now we're up to this illegal move. Interesting. It's illegal, not ambiguous. So the move is for black to go. Oh, I see why. Because of the castling. It looks like it's because of the castling. So let's take a look and just run through this. So rspec pipe less. And actually, while it plays through the game, let's go through here. After it makes the move, let's print it out. So game followed by the position followed by the move. Okay. And okay, save it. Game, right. We need to say game is equal to 1. All right. So we haven't finished with the first game, so that's why it's all going to be 1. So let's see. Let's see what happened here. Okay, illegal move. Oh, yeah, let's go backwards a little bit because I think I just saw it. Okay, I'm going backwards now. Okay, it's from here. Okay, so here it is. So this move is a castle, but you see that the rook didn't move to the other side, so it was only one move. So this is the responsibility of move piece. So the move piece handles the mechanics of moving the piece. All right, so let's go back and go to move piece. Okay. Oh, no tag for move piece. So C tags. I thought I just ran C tags. Okay, so let's look for move piece. Okay, so we're able to find it now. Okay, so oh, this only does the en passant capture, but it doesn't do castling. So if it's a king, so let's add some logic in here saying that if it's a king, let's see, if piece is a king and you move sideways, so see, there's no dxdy, so it's like 2 minus from absolute value is equal to 2. So you move 2 squares to the side. Then we want to also move the rook. So actually, let's do it over here because it's after the king moves. So in this case, we want to make sure that the let's just set the to and from. So the rook happens to be a, well, if the two, actually let's make this more explicit. So no, we'll keep it like this, and we'll say like because it can be long castle or short castle. So if it's a long castle, let's put the logic in here first. So if it's a long castle, so oh, how do we know which direction it is? Okay, so the two direction, if, okay, so in this case, this is the, let's put a little comment in here because this is kind of hard to tell, is smaller than the from. So you're going to the left. So this is the long castle. So in the long castle, we want to and from to be, well, the from is actually going to be the same. So from is going to be, if it's white, it's going to be, based on the turn, it's going to be E1 or E8. So that's true. It's just a 2 that we need to figure out. So if it's a long castle, oh, then we can just do it here. 2 is equal to, okay, so from a long castle, it's going to be turn, let's do the short castle. Okay, so from and to, so this way it is G, or not G, F1 and F8. That's where the rook will go. Actually, this is wrong too. Okay, because I got confused with the king, because this is the rook that we want to move. The rook starting point, if it's a short castle, it's going to be from H1. So the from and to will be from H1 to F1. Otherwise, it's going to go from A1 to not C, D1. Oh, I'm missing a parentheses for this white over here. Okay, so let's see, all the parentheses seems to match now. Okay, looks good. Okay, so then we just do the movement. So self to is equal to self from, and self from is equal to empty. All right, so this should take care of it. Oh, and then we have to say if act. Okay. Okay, so we need to create king. So let's find out where pawn is located. And so we'll just do it in the same spot. So king, self is equal to k, or okay. It went through the whole game, and it ended up with the ending notation. So let's go and start up a new game here. So so this went fine, and so we say if, or case m, when it looks like yeah, I think we can just get away with if. We'll just, since we're here, okay. So it's going to look like 1 0, or actually I'm going to turn this into one of these regular expression things, because I'm going to use slashes. or it's going to be 0, 1, or it's going to be 1/2, 1/2, $, or it's going to be a star, which means it's an incomplete game. Okay, so when it's this, then we want to start a new game. So position is equal to new position, position.new, and we increment the game counter. Okay, otherwise we'll go through and actually make the move. All right, so now we have a promotion. This is different. So let's go to the promotion and add that in here. So this is an optional element here, so it's going to be equal promote and a piece. It'll be rook, knight, bishop, queen, no king, no pawn. Okay. All right, so this should handle the promote, and we need to be able to do something with the promote. Okay. Actually, the promote doesn't come into play until the very end. So let's go to the very end where you've actually moved a piece. And right after you move the piece, if the promote exists, if promote. Okay, we have the 2 square. We know where the 2 should go. So we just need the promote piece. And self 2 is equal to m promote. But we have to do the right color. So send, depending if you're white, and a turn. Okay, this is before you've changed the turn, so still base it on the turn. It's going to be upcase or downcase. All right. All right, so this should promote the piece. Oh, actually, this is not correct because we have to convert it into a symbol afterwards to sim. All right. All right, next, no method or bracket for nil class. So we've got a nil in here, line 200. So where's 200? Right here. So promote. So we know that this is not nil because we just checked right here, and we're sending it based on a turn. So this should not be nil at all. Um, if promote. Okay, and it's after you've made the move. All right, I'm going to check one more time. Undefined bracket for nil class. $200. All right, so let's see what's going on. So I'm going to put like a, I'm going to okay, put a little debugger in here and check the state of what's going on. Okay. Oh, it didn't even get there. Line 200. Oh, of course. The reason why is because uh, M is over here, and I'm not in this if clause. So I don't have access to, there's no guarantee that this is going to be set. But uh, more than that, M may not even be defined. Okay. So, let's see. So I'm going to create a promote variable here and say that it's nil, and just define promote is equal to M, and then I'm going to put the right piece here. So actually I could just take this whole logic here and put it up there. So where did I put promote? Right here. Okay, if promote. So now I don't have to do this. I can just say is promote if it exists. All right. Okay, it looks okay. So we went further along. And now this is probably something that we've seen before, where it's an ambiguous move because it doesn't know which rook to move. But we know that we can't move this one because it's pinned, so we have to uh, look for check. And so what we're going to do, instead of writing a function just for check, we're going to create a function. Let's see. Let's move out of here and actually let's put some character terms. So move piece, and where does this move that? Okay, just bring a little character turn so that'd be easier to navigate. So we have move piece, but we need to write attacked. I want to see if something is being attacked. So let's write some tests. So if you have a regular position and you say attacked, actually we want a position. So E1, which is where the king is, attacked by black, and attacked by black, and that should be false because it's not. If we have a position with a rook on a king on E4 and a black rook on E1, it is being attacked. And so you want to say attacked on E4 by black, and this should be true. All right, so let's see. Should get an error because undefined attacked, and attacked should be okay. So let's write attacked. Okay, and it takes in 2 and color. Okay, so we start off with all the pieces. So rook, knight, bishop, queen, king, pawn. So these are all the pieces, and I'll turn them all into symbols. Map. Okay, and so these are the opponents. And opponents we want to downcase if color is black. Okay, so we're going to go through each one of these. So opponents, any, are any of these, and then we have the opponent. Okay, so we take the pieces and look for the opponent, and are any of these true? And this is where the from is, and we want to check if this is a valid move, a valid capture. So we start with the piece. So opponent, valid capture. This is just the movement, so it doesn't check to see if the path is clear, so we have to do another check for that. Okay, so we have the opponent, it's a valid capture from 2. Okay, and the path is clear, so path clear from 2. So there's nothing in the way. Okay, is there anything else that we need? Okay, I think this is it. So let's see. Okay, so it didn't pass the first test. It should have been false, but it, oh, oh, the variable black. This is part of somewhere in here. Okay, there it is. It's supposed to be. All right. No method error down case for an array. Oh, that's because I'm supposed to map it. Map down case. Okay, it looks good. So we have attack now. We can use that to see, we can filter out the moves. So going back to the code, going to move. Okay, the question is on the move selection. So we want to filter out any of these that would cause, actually I'm going to move the move piece check over here because I want the simplest calculations to be done first, followed by the more complicated ones. So move piece would be there. Okay, so we want to check to see if it's a check. So if the king is being attacked. All right, so let's do that. So list select. Okay, so the king has to be safe, and we have the from. Actually, we don't need. Do we need from? Yes, we do need from because we need to make the move. All right. So let's make a copy. We have to actually make the move in this case. So let's make a copy of it. So we'll call it temp, and it's a duplicate, but we'll make the move. So move piece um, from to. But we have to be careful about dupe here. So I'm going to write a little test for dupe. See, for now I'm just going to return true, and we'll come back to this because okay, we're in insert mode. Okay, so where was I? Oh yeah, the dupe. So let's write a check for dupe. Um, so let's say that we have a position. Um, actually, we have a subject. We have position already, which is the subject, and we'll make a copy of it. So position is equal to subject dupe, and then we'll change the subjects. The subject's E4 is going to be a rook. Then we want to check the position. So we expect the position E4 to still be blank. Equal this. Okay, so this is our test, and it should fail, and it does fail. So we need what we need to do is go to, let's see where initialize is. Oh, there's a lot of initialize. Okay, so we're here. Let's see where this ends. Okay, so we'll just start from here. Def initialize copy takes other. So when we copy it, we're going to copy. So let's list this out. So we have the board. Okay, so for the board, it's going to be the other board, but we're going to dupe it because that's an array. Then pieces is the other pieces, but we also going to dupe that. What's next? We have the turn. We don't need to do that, so we just be the other's turn. The castling, yes we do because that's a list, so other castling dupe. And en passant, that's just the numbers. And half move, other half move. Full move, other full move. Okay, so this should be good. Okay, passes the test, and now we're back to the ambiguous, so let's go back. Okay, so we're back to the code where we left off, and here it is. Okay, so this is where we left off. Okay, so now we make a temporary copy, and then we do the move on it, move piece from 2, and we know that this should be fine because we did the test over here. So everything should have passed. And now we check to see if it's safe. So temp.attacked, it's not attacked, the king. So we need the king position. We have to figure this out. And for the color, depending on the turn, if it's white, then it's black. So it's the other guy's turn. So the other turn. So we need to find out what the king index is. So let's see. Oh, this only happens if the king exists. So let's just start off with the king index being equal to null. And we're going through the if king index is equal to at pieces the king, the right king. So that would be, if you're white, then it's going to be a capital K, otherwise it's going to be a lowercase k. All right, so we have the king, we have the locations, and we just want the first one because there may be more than one. So to array and the first one. If it exists at all, okay, I'll just say king list, and king index is equal to king list.empty, then it's oh, we don't even have to say that. We can just put an if condition here. So if it's not empty, then we do this whole thing. Otherwise it'll be false there. So we can make it explicit, say else false. Okay, so don't select those. Okay, king is empty, it's not empty, so the king index is going to be just the first one. So king list 0. Empty, oh, that's because I need a question mark. Okay, it's running through. Illegal move king to h1. Okay, king to h1. Oh, the reason why is because this is the current king's position. We don't want if the king has moved, then you don't want the current king's position. You want where the king is going. So, okay, so if the piece is a king, then you're moving the king. So then you want the 2 position. Otherwise, you want where the king was. So you don't want to look for the king if the king is going to be moving. Okay, so let's see. All right, much further. Illegal move knight c e5, c to e5. Oh, this is an illegal move. Oh, this is, yeah, it is black's turn. Okay, c to e5. All right, so let's look through the game. Okay, so let's RSpec this and go all the way to the end, and it's on game 47. So we've made a lot of progress. So okay, so game 47. So let's see what happened in the game. Okay, so let's see. I'm looking down here. So okay, so far so good. It looks like normal moves. Bishop pins the king. Knight attacks. Castles. Queen out. Pawn. Knight back. Okay, knight to g6, which is good, and g4. And there's actually 2 knights that can go to, yeah, illegal move c to e5. So this knight can go here, but it's saying it's an illegal move. So let's see what happened here. So what it looks like, what I think may have happened, game 47, is let's see if that knight is a possibility. So let's take a look at, so when I'm printing this out, let me print out all the knight squares. So what I'm going to do is go to the 2S, and when I'm printing it out, at the end here, I'm going to print out the at pieces. It's a black knight. I want to see where the black knight is located, and map to square on it, and inspect. Okay, let's see if this will work. Okay. All right, so okay, so we see that there's something wrong here. Let's take a look at how it runs game 47 and see where it disappears. So we're looking for, let's look over here and look for the where, okay, it just happened. Okay, let's move up a little bit. So from here everything's fine, but when it went here, that knight disappeared. That's very interesting. So that is very interesting. Why it disappeared? Oh, I think, okay, so let's take a look. This, okay, let's take a look at the code. So let's take a look at where everything gets removed. So there's okay, so where does it get removed? This will probably be the last bug, and then we'll probably wrap this up. Okay, so the knight is over here, and it just disappears after you've made this move. Actually, this is after it's made, so okay. Oh, actually, what we could do is we could stop on game 47. Let's do that. Instead of trying to figure out where it is, we can just step through it. So we'll go to here, and we'll set the debugger if game is equal to 47 and see exactly where it happened. And the move number is 8. Oh, actually, this is after the ninth move. So on the ninth move, and position dot full move is equal to 9, and whose color? It is white's turn. So we'll just actually it is, yeah, it's, this is after its move. So we wanted to stop on 8. So 8, and it's black's move. So position turn is black. Okay, so let's step through it. All right, so let's step through. Okay, and let's display the pieces n. Okay. Where is, oh, there's the pieces n. So it's a set. Oh, it doesn't look very good. See, can I delete it? That's not, that's on display 1. Okay, let's display at piece n map to square. Hmm. Let's see. That doesn't look very good at all. Um, well, okay, let's just step through here. Actually, we have the list right here. Okay, let's take a look at the list. Okay, piece is an N. Okay, pieces night. Okay, so we still have two, which is good. And move piece. Let's just get out of here because let's get out of there. This is move. Okay. Let's take a look at pieces N. Okay, so still good. Is en passant capture. Let's just get out. And all right, so we're back here. Let's take a look. Okay, so we still have two choices. PM call. P97. Okay. So move piece false. So that one should not do anything. Okay, let me just get out. Okay, so now I'm back out. So let's take a look at list. List is still those two. And determine if you're in check. Okay. Oh, I think I mean no. Let me see. Just have to jump out. No, this looks still fine. Um, okay, so it looks. The first one looks fine. Okay, so this should be included. So let's just jump out. Okay, and each attacked, each path clear, each. Okay, okay, so now let's take a look at the from now. This is 18. Okay, so this is the other night, and this should not be included. Okay, just jump out of here. Let's take a look at act. Oh, this is true. Okay, that's right. Okay, you should be working on a copy, so the temp should not affect. So let's see what the temp looks like. And uh, temp. Okay, so in the temp, it's doing a check to see if this leads to check, and it will be. So let's take a look at self. And oh, that's really interesting. Did you notice that this has changed? Hmm. The self should not have changed. So it looks like the pieces. I mean, this should not be the case, but like something's up with the case, the pieces. So let's go to initialize copy. Okay, here's, okay, initialize copy, and it is being duped. So it should not have been modified. So let's go through this again. Okay, and just step through. Okay, so this is under move, and let's put a breakpoint somewhere. So let's just put a breakpoint. Let's see, where should we put it? Actually, let's display pieces for n and have that as inspect. Oh, on display, I mistyped it, and display at pieces and inspect. Okay, so let's just step through. Okay, I'm paying attention to this. Okay, so there's the move piece, and it's set to false. Okay, I'm just gonna, okay, and jump out. Okay, so far so good. And now we're getting to the king, checking for the king. King list. Oh, no, this shouldn't have anything to do with this. Okay, so let's go in there. Okay, so far it's still 6 and 18, and I think 18 will disappear. So let's see how that happens. All right, king index. We duplicate. Temp is a duplicate of move piece. Okay, so we duplicate it and then we move the piece. So there. Okay, and we just jump out. Okay, so it moved the piece, everything is fine. And continue. So next. Finish. Attacked. Let's step in through that one. Okay, we just jump out, still jump. Okay, so now we're up to the next one. Okay. Move piece. Okay, so in that move piece, something happened in there that caused the set to be changed. So now that we know, let's just rerun this. So okay. All right, so we're here. We just step through. And it's part of, let's see, we have to get past this point. Okay, so it's on, put a break on 208. Okay. Oh, this is really interesting. I I did a move piece here, and I did a move piece again. So this shouldn't really make a difference because, yeah, this should really make a difference in the current position, but there's something really wrong. So I'll put a break on 207, continue, and I'll put a display at pieces n map to to square on it. Actually, I think inspectable is just good enough. Okay, and what piece am I working on now? So from is on 6. So continue from 6 and display from. Actually, it's not from. Move, yes, from. Display from. Continue. All right. Okay, so all right, so we're back here, and let's continue. Okay, so now we're at the point where it's changed. So we'll step through here, move piece. Okay, pieces. So 2 equals piece if act. Okay, from, remove it, and that removes it, which means that the set, even though it's supposed to have been duplicated, is not. Okay, let's go back up. Okay, let's quit. Okay, so there's something seriously wrong with our copying. Okay, so we don't need this anymore. Okay. All right. We know what the problem is, and okay, so actually let's try with the okay, so here's temp. Let's see what happens if we just get rid of the first one. Should still be the same error. Okay, so we still get the same error. So the problem is inside of this move, even though we've duplicated it, it's still it hasn't changed. And let's write a test to see if we can reproduce it. So it's part of dupe. So attacked, move piece, and there's dupe. So instead of subject E4, okay, so we'll create another test on we can access pieces through this way. Let's try subject move piece from E2 to E4. Okay, and so in the normal position, the E4 should still be blank because this one moved it. So let's see if it causes an error. No, it passed the error. So that's very weird because it's behaving exactly the way you would expect. Um, huh. I think I may know why. All right, I think maybe this is why. No, we still have the same problem. So we duped it, and then we uh, moved the piece from temp. Self.dupe. Should have the same error. Okay, so I'm going to take a look into this a little bit more, and we'll catch up on the next session.